Netskope helps organizations secure their digital transformation with a modern, cloud-native security platform that follows users and data everywhere they go. Zero Trust Network Access is one of the core pillars of functionality available as part of the Netskope Security Cloud platform. The Netskope Security Cloud platform enables fast and secure access for any user anywhere on any device, accessing cloud apps, websites, and internal apps. Instead of remote user traffic being hairpinned back through security appliances deployed in the data center, users going through Netskope benefit from Netskope New Edge's network and get fast on-ramp performance with an optimized path to their destination. For users accessing cloud apps and websites, Netskope's Next-Gen Secure Web Gateway functionality provides advanced threat protection and zero trust data protection. For users accessing internal apps that are not public-facing, Netskope's Private Access provides zero trust network access. This will be the focus of this demo. One of the key advantages of Netskope Private Access versus a traditional remote access VPN is it is more secure. VPNs provide access to the network segment where you can move laterally. Netskope Private Access provides secure access directly to the app. Let's perform a side-by-side comparison. We will start by accessing a target app resource. With the VPN, users typically need to launch the VPN client and log in. No such requirement with Netskope Private Access. Netskope is always running, is transparent to the user, and all zero trust access policies are orchestrated in the cloud. Now that we have been granted access, let's perform a port scan to see what systems are available. As expected, Netskope Private Access shows the one internal app that has been granted access. The VPN, on the other hand, presents an opportunity for lateral movement, and I can access any of these systems. This presents a big security hole because I can be an employee with malicious intent or a bad actor that has stolen credentials. The next comparison is end-user performance. VPNs were not architected for the work-from-anywhere user. Users normally can only connect to one VPN concentrator at a time, and most organizations run a single VPN concentrator or cluster in a central location. Now, in this scenario, I need to access a private trading app, and there is internet congestion on the route between me and the target application. This is a result of the need to go through New York, where the VPN concentrator is located, before being directed to the app destination, which is London. Netskope Private Access is optimized to deliver superior end-user performance. Netskope's fan-out architecture eliminates the need to route users to a VPN concentrator. All access via Netskope Private Access gets an optimized, uncongested path over Netskope's New Edge network with no reliance on the public internet. Let's compare the performance of a VPN configuration versus Netskope Private Access when accessing the internal trading app. So we will go ahead and start our timer. And as you can see, the trading app already completed the loading of the page with Netskope. Now the VPN, on the other hand, is very sluggish and slow. Terrible end user experience. And we're probably going to get some complaints to our IT help desk. Addressing lateral movement risk and improving end user performance are two big value propositions delivered by Netskope Private Access. But last and certainly not least is employing zero trust decisions when granting access to internal app resources. Never trust, always verify is fundamental to a zero trust network access architecture. Let's take a look at how this works. Here is a scenario where Bob and the marketing team needs access to his company's internal learning management system. By default, all access to the LMS app is blocked, and only users that are trusted will be granted access. In this case, the criteria for trust is the identity of the user, and specifically the fact that Bob is on the marketing team. Next is the device. We will only allow access from a managed device that has not only had the Netskope client deployed, but the device needs to be running CrowdStrike endpoint protection and the device's hard drive needs to have been encrypted. Now, once the trust criteria has been met, we can grant Bob access to the app. However, since Bob is in marketing, he only gets access via a browser and cannot access the app via other means like SSH. SSH access is the focus of the next scenario, where Frank on the sysadmin team needs SSH access to the server hosting the LMS app so he can patch the server and apply ongoing updates. Frank is not permitted to access the highly confidential data in the LMS app. In this case, we will verify the identity of Frank and that he is indeed a sysadmin. We will also ensure Frank passes the same device posture checks as Bob in marketing. Now, once the trust criteria has been met, we will restrict access to Frank to SSH only. Deployment and ongoing operation of Netskope Private Access is simple given the cloud-native architecture, unified policy engine, and same Netskope client footprint used for other Netskope Security Cloud services. Now, once we have deployed Netskope publishers where our internal apps are hosted, the first step is we want to define the app resources we want to grant access to. For this use case, we need two resources, one that is tied to browser access to the internal app so that we need to specify 80 and 443 as our ports. The other resource will be tied to SSH access, so port 22 obviously. Now that we have our app resources defined, let's create a Zero Trust Network Access policy. Netskope Private Access uses the same unified policy engine that is used to deploy Zero Trust data protection policies for SaaS, IaaS, web, and email. Now we will start with identity, and in my environment I have Okta integrated. We will choose marketing as the group. We will also restrict access to Mac and Windows, and will restrict the device classification to only managed devices where we have configured running CrowdStrike as the endpoint or on the endpoint, as well as disk level encryption that's enabled on the device. Those are two important device posture checks that we'll perform. We will then choose the app resource, in this case, browser access to the LMS app, and the action will be allow. Now we are effectively performing criteria checks on identity and device posture, and as a result, providing restricted app access via browser only. For the second policy, we will choose sysadmin group as the identity, use the same device posture checks, and we will grant restricted access to the LMS app via SSH only. Let's verify the Zero Trust Network Access policies. Here I am logged in as Bob at bobsbank.net. Now I'm a member of the marketing team. I am also using a managed device, which is CrowdStrike deployed, and the disk on my machine is encrypted, so I'm passing the posture checks. Now let's go ahead and try to access that internal app resource. As you can see, I get lightning fast direct access, no VPN client to configure and connect with, all transparent to the end user. Let's switch to a machine used by Frank Altos, one of our sysadmins. And the first thing I'm going to do is try to access that internal LMS app from my browser. It looks like I'm not being granted access. Let's verify my identity. Oh, that's right. Because I'm in the sysadmin group, I only have access to SSH. Even though I passed the device posture checks, my identity says that I have restricted access. So let's go ahead and close this and let's go to SSH, which is what I need anyway because I need to patch the server. So as I get SSH direct access, again over the New Edge network, directly to that server, lightning fast, and all transparent thanks to Netskope Private Access.